Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are on lecture number 27 of Algebra and the fourth and the last lecture on sequence. So let's get going. Let's look at this question. It's a question about right angle triangles. The diagram shows a sequence of right angle triangles ABR1, ABR2, ABR3, all with height AB equals to 1. So let me just do a little bit of highlighting. So now I have drawn the height, that is AB, that is 1. And then let me draw the base, which is BR1, that is the base. And then what I see is the hypotenuse that's right over here. So what I see is a right angle triangle. Now the question is, what exactly are they asking? Now, in the first part, they are asking this, that is BR1 is 1. So they are asking about this, that BR1 is equals to 1, and that is already given. That is 1, and this is 1 actually. And the height is already fixed. And how is the hypotenuse changing? That is what we are asking. Given that AR1 is equals to root x, show that x is equals to 2. So I want you to get started with this. So basically, I can say that AR1 square is equals to AB square plus BR1 square. So therefore, this is 1 square, this is 1 square, that is 1 plus 1, which is 2. This is AR1 square. So therefore, AR1 is root of 2. They are giving us that AR1, the green thing. Let me just highlight this. So the green thing, AR1 is root x, AR1 is root 2. Therefore, I have proven that x is equals to 2. So x is on the inside, x is equals to 2. That is answer of part A. That's the first part. Now, let's try out the second part. Why don't you take the lead and try it out? Yes, again, it's Pythagoras theorem, but there is some instruction that is given over here. What is the instruction? Now, the instruction is this. In the second triangle, BR2 is AR1. So BR2 is AR1. AR1 is the green one. And let me highlight this thing, which is BR2. So now let me draw it like this. This is BR2. This is like this. And then let me use a different color. Let's say, for example, the orange color. And now I'm focusing on this. So basically, this one is fixed. BR2 is AR1. That means this is root 2. And now I'm focusing on AR2. So let me write it down for part B. So for part B, I'm writing it down over here on the corner. And this is, I'll say, AR2 whole square is equals to AB square plus BR2 square. AB square is 1 square. BR2 is root 2 whole square. This is 1 plus 2. This comes out to be 3. Therefore, AR2 is square root of 3. Let me write it very clearly so that there is no confusion. So therefore, I have proven the fact that in part B, the orange part, this one, show that AR2 is root 3, AR2 is root 3. So this thing is also done. So two applications of Pythagoras theorem. Now it says the sequence continues. And what happens with this sequence? The sequence continues with BR3 is AR2. So now the new base, BR3 is the same thing as the previous hypotenuse, and so on. Show that R1 is the midpoint of BR2. So now let me just make a pattern over here. And I know that AB is 1. That's the first thing. I know that BR1 is also 1. And similarly, AR1, that was root 2. So I'm referring to this particular thing. That is root 2. That's right over here. Now, for the next triangle, what is happening? that AB is still 1. So this is fixed. So let me write it twice or thrice. Let me write it 3 times. And BR2 is AR1. That is root 2. So therefore, AR2 is root 3. Similarly, BR3, this is root 3. So BR3 is AR2. Now look over here. BR3 is AR2. BR3 is AR2. BR2 is AR1. That is the pattern that's going on over here. So therefore, AR3 is root 4, and root 4 is the same thing as 2. They're first asking us this thing, show that R1 is the midpoint of BR4. So what should I do? I think let me draw a line like this. And let me just draw it over here. So this is A. And then AR1 is root 2, AR2 is root 3, AR3 is root 4. So let's say this is R3 and AR3 is root 4. And they are asking AR1. So let's say this is R1. We know that AR1 is 1 unit. And AR3 is root 4 or 2 units. Hence, in other words, I can say that R1 is the midpoint because this is 1 unit, it's half of 2 unit. So that is the answer of the first part. Now it's asking, find the sides of the 10th triangle. And it's asking, write down in terms of n, the side of the nth triangle ABRN. Now, when we are talking about this, let me just shift the C a little bit over here. And let me just focus this like this. And over here, what is happening is that we are talking about a particular triangle. For example, the first triangle is ABR1. So let me write over here. This is triangle ABR1. This is triangle ABR2. This is triangle ABR3. Now, in all of them, this AB is fixed. That's the first thing. BR1 has a value of 1. BR2 has a value of root 2. So I can even write 1 as root 1. No harm in that. BR3 is root 3. And what about AR1? So if this is 1, this is 1 more. This is root 2. AR2 is root 3. AR3 is root 4. So now a pattern is developed. And for part 3, for C part 2. So if I write triangle ABR10, and for part 3, C part 3, that is ABRN. Now the pattern is very clear. So we will write AB equals to something, which is 1, that is fixed. And BR10 should be root of 10, because whatever is the value over here, that is the root over here. And therefore, AR10, that should be 10 plus 1, which is root 11. Similarly, over here, AB is still 1. BRN, that is root n, and ARN, that is root of n plus 1. That is the pattern that is over here. Let's double check. So now that was the basic thing. This was known. This is the half thing. This is 1, root 10, root 11. This is 1, root n plus 1. And that is how this particular question is done and dusted. So a very classic question. Now let's talk about a quadratic sequence. That is the main theme of today's class. What exactly is a quadratic sequence? So now let me just check one thing, whether the voice is all good, all on. Yes, it is. So what exactly is a quadratic sequence? Before that, let me write n equals to 1. So T1, that is a into 1 square, which is a plus b plus c. That is the first term. That means a quadratic sequence, as the name suggests, should have an n square term, an n term, and a c term. That means there is a quadratic term over here, just like a quadratic equation. So now we want to go into the depth of it. How can we realize that such is a quadratic sequence? Now, if you remember, if I go to the very first class notes, we saw some kind of quadratic sequence over here. There it is. A quadratic sequence is something in which the second difference is constant. For example, I wrote this thing, n squared plus n plus 1. I wrote T1 is 3, T2 is 7, T3 is 13, T4 is 21, T5 is 31. The first difference is an arithmetic sequence. The second difference is a constant. That's what makes this thing a quadratic sequence. And we were just focusing on that. So now if I come over here and I continue the journey right here, so I'll write this thing that the first difference forms an arithmetic progression and the second difference is constant. Keep that in mind. So that is what the quadratic sequence is. Now I want to work it out. So now the thing is that we will write, when we are writing n is equals to 1, T1 is a plus b plus c. If I write n is equals to 2, T2, that is a into 2 square, b into 2 plus c, that is 4a plus 2b plus c, that is the second term. If I write n is equals to 3, therefore T3, that is a into 3 square and b into 3 plus c, which is 9a plus 3b plus c. And I can create many more terms like this. Now, if I find the difference between these two terms, between this and this. So let me focus on this. So the first difference between the first two terms, that is 4a plus 2b plus c. And this is a plus b plus c. And if I'm looking at the difference, what do I get? I get 3a plus b. That is the difference between T2 and T1. That is what I'm getting. Now, similarly, let me find the difference between these two. 9a plus 3b plus c. And this one is 4a plus 2b plus c. And if I look at this difference, what do I get? 9 minus 4, that is 5a, and this is b. So this is the difference between T3 and T2. Now, if I find the difference between the first differences, so now 5a plus b minus 3a plus b, the b's cancels out. It's not 2b, it's just a b. The b's cancel out and I'm left with 2a. That means the second difference comes out to be 2a. That is the thing that I have obtained. So now let me highlight three things out of this. The first term over here. So first term is what? That is a plus b plus c. That is a plus b plus c. That is the first thing that I've obtained. Then the difference between T2 and T1. So let me just write this. That is 3a plus b. And what else is there? The second difference is 2a. So these are the three things that I'll be using. Now, how can I use this? That is the main thing. Now, let's say this is worked example 1, just the basic worked example. And I have 0, 2, 6, and 12. Now, the first thing, the difference between 0 and 2 is 2. The difference between 2 and 6 is 4. 6 and 12 and 6. This first difference is an AP. Yes, it's a quadratic sequence. Why? Because the second difference is constant, which is 2. So since second difference is constant, that means it's a quadratic sequence. That is the first thing that you need to realize. Now, what else needs to be done? What we need to do is that we will write Tn is an square plus bn plus c. We have to find the values the value of A and B and C. And that is what we have to work out. So we will start with this thing. Second difference is 2A. So first of all, second difference, 2A, that equals to this 2 that's right over here. That is this one, that is this one. Of course, it's the same. Therefore, the value of A comes out to be 1. That is the first. Now, if we have this, the difference between T2 and T1 is 3A plus B. So the difference between T2 and T1, that is equals to 3A plus B. So the difference between T2 and T1 is 3A plus B. So let me just change the color over here. The difference between T2 and T1 is 3A plus B. Therefore, 3A plus B. This equals to what? This equals to 2. That is T2 minus T1. That is 2 minus 0. 3A plus B equals to 2. 3 into 1 plus B equals to 2. Therefore, B comes out to be -1. That is the second thing that we obtain. So first we use this thing. That is the first difference. And then we use this thing. The difference between T2 and T1 is 3A plus B. So this over here was T2. This over here was T1. And this is giving me B is equals to -1. So A is found, B is found. And what is the last thing? And let me also change the colors over here so that it's easier for you to realize. So I'm using second difference, that's the blue color. So second difference, that is not this, that's the blue color. And this one, 3A plus B, that is T2 and T1. 3A plus B, that is T2 and T1. And first term is A plus B plus C. And first term is A plus B plus C. And this first term equals to what? This first term equals to 0. So therefore, A plus B plus C equals to 0. What is A? 1. What is B? -1. What is C? C. What is this thing? 0. Therefore, coincidentally, C comes out to be 0. Therefore, what is Tn? That is an square. This is 1n square. And this is -1n plus C, which is 0. Let me add a page and I'll double check this. So therefore, Tn is equals to n square minus n. That is the quadratic sequence. And that is the kind of working that needs to be done. Now let's double check. N is 1, n is 2, n is 3, n is 4. This is just for checking so that I'm very, very sure that I'm on the right track. So I should be getting 0 and 2 and 6 and 12 out of this. So let's double check. So T1, this is 1 square minus 1, which comes out to be 0. T2, this is 2 square minus 2. 4 minus 2 is 2. T3, that is 3 square minus 3, 9 minus 3, which is 6. And T4, which is 4 squared, 16 minus 4, which comes out to be 12. So 0, 2, 6, 12. Is that the answer? Yes, that is the answer. So this is all good, all clear. Give yourself a star if you have understood this thoroughly. Now, apply the same process over here. So let me just pause the recording. Let me share this slide so that you can try it out, and then we can continue with the journey. So now over here, if I solve this question for you people, so the thing is, first of all, what is the first difference? 8 and 14, that is 6. 14 and 22, that is 8. 22 and 32, that is 10. It's an AP. Yes, it's a quadratic sequence. This is the first difference. Now the second difference, that is 6 and 8, which is 2, 8 and 10, which is 2. The second difference is constant. So if the second difference is a constant, yes, it's a quadratic sequence. So we will write Tn is equals to an square plus bn plus c. And what exactly are we looking for? We are looking for the values of A, B, and C. Now, this is the knowledge box that is needed. So let me just copy this thing out. So let me just erase this. Let me just copy this so that this should be handy. So let me just write it over here in the corner. Let me minimize it. And that is exactly what we are working on. So just let me remove this. So now, first of all, how do we get started? We will start with this last thing. Let's say this is like equation 1. This is equation 2. This is equation 3. We start with the third one, 2a. So let me just write it. This is 2a equals to this value, the second difference, which is 2. Therefore, a comes out to be 1. So that is the first thing that we have obtained, which is a comes out to be 1. Now, let me move to the second part, which is the red part, which is 3a plus b. So this is 3a plus b equals to the difference between T2 and T1. So 14 minus 8, which is 6. So therefore, this is 6 and a is 1. 3 into 1 plus b equals to 6. Therefore, b comes out to be 3. So the second part is also done. So just look at the working style in which I'm working. So that will make your life a bit easier. And now the last thing, the green part, that is this. That is what? That is a plus b plus c. That is equals to the first term. A plus b plus c equals to the first term. What is the first term? Which is 8. So what is a? 1. What is b? 3. C is c, and this is 8. Therefore, c comes out to be 4. So therefore, what is Tn? That is an squared. That is 1n squared plus bn, which is 3n plus 4. So therefore, this is n squared plus 3n plus 4, and that is the quadratic sequence. So it becomes of second nature to you, and that's how this thing is done. There are some more examples over here. And now let me move to this particular question, which is a past paper question. Now let's read this one. It says a series of diagrams of shaded and unshaded small triangles are shown below. So there is shaded, there is unshaded. The shaded triangles are those which have at least one side on the edge of the big triangle. So which ones are the shaded ones? That is one side on the edge of the big triangle. Okay, that thing makes sense. And hold for a second. Yes, I'm getting this thing. So the shaded have one edge, at least one edge on the side of the big triangle. All the other small triangles are unshaded. So these are unshaded, and that's how the story goes. Excuse me. Copy the table below. And now it's this filling in the table, which shows numbers of small triangle. Diagram number 1, 1, 2, 3, 4, 5, n. Number of shaded triangles, 3, 6, 9. This is x. Total number of triangles, which is 4. Number of unshaded triangle, 4 minus 3, which is 1. 9 minus 6, which is 3. 16 minus 9, which is 7, and so on. So they could also have written number of shaded, number of unshaded, and then the total. But instead, they chose to write it like this: number of shaded, total number, and then the number of unshaded. So let me just focus on each color. So this is the red thing. That is 1, and then 2, and then 3, and then 4, and then 5. And this is in terms of n. Let me focus on the total number first, because I'm just looking at that. This is 2 square. This is 3 square, 4 square, 25 square. So y is basically n plus 1 whole square. It's square numbers. So for first diagram, this is basically 1 plus 1 whole square. For the second diagram, this is 2 plus 1 whole square. For the third diagram, this is 3 plus 1 whole square. So therefore, this is y is n plus 1 whole square. So I'm just first looking at the diagram and then fulfilling whatever I feel is necessary. Now, if I talk about this thing, that is number of shaded triangle. This is 3, 6, 9. This is an AP. This total number, that was like a square number thing. So now if I talk about the AP 3, 6, 9, and so on. So let me write over here, Tn is a plus n minus 1 into d. That is a arithmetic sequence. The first term is 3. The common difference is 6 minus 3, which is also 3. So therefore, Tn is 3 plus n minus 1, which is n minus 1 into d. This is 3 plus 3n minus 3, which is simply 3n, which also makes sense. So basically, I calculated it using the AP formula. But this is like 3 times 1, 3 times 2, 3 times 3. So let me fill it up. 3 into 4 is 12. 3 into 5 is 15. And let me also fill this blue one up. So this 5 1 is 5 plus 1 is 6, which is 6 squared, which is 36. Nothing is done. Now, what about this one? That is simple subtraction. Nothing special as such. So this is total minus shaded will give me unshaded. So 4 minus 3 is 1. 9 minus 6 is 3. 16 minus 9 is 7. 25 minus 12 is 13. 36 minus 15. That is equals to 21. So what is Z? So Z is basically, let me write. And by the way, one more thing. This Tn is actually X. So X is 3n. And what is Z? So Z is basically the total number, which is y minus x. What is y? Y is n plus 1 whole square. And what is x? X is 3n. So this is n squared plus 2n plus 1 minus 3n. This is n squared, and this is minus n plus 1. That is z. Basically, this is a quadratic sequence. Now, remember, in this one, I obtained the quadratic sequence based upon the concept of subtraction. I did not apply what we just learned over here. This was not applied as such. So if the need is there, I can apply it too. So let me write 1, 3, 7, 13, 21. Let me add a page. So 1, 3, 7, 13, and 21. And let's say if it's really a quadratic sequence, of course it is, but there is no harm in double checking it. So 1 and 3, the difference is 2. 3 and 7, the difference is 4. 7 and 13, the difference is 6. 13 and 21, the difference is 8. Yes, it's an AP. It's an arithmetic sequence, progression. 2, 4 is 2. 4, 6 is 2. 6, 8 is 2. So if someone wants to calculate it this way, that is also possible. So let me grab that data sheet that is right over here, and let me paste it over there. And where it is over here, so I can even calculate it in this manner. So therefore, the second difference, so we are starting with equation 3. That is 2a. The second difference is equals to 2. Therefore, a comes out to be 1. It's just a beautiful coincidence that in all the questions that I did, I'm getting this thing. The difference between T2 and T1 is 3a plus b. So T2 and T1, this difference. So that is 3a plus b equals to 2. Yes. And 3 into 1 plus b equals to 2. Therefore, b comes out to be negative 1. And then the last thing, a plus b plus c is the first term. The first term is 1. And this is a is 1, b is negative 1, plus c equals to 1. Therefore, c comes out to be 1. So let me again highlight this thing. We started off with the blue thing using equation 3. And then using equation 2, we found the value of b, which is the red color thing. No, over here. So that's the red color thing that we found. And the last but not the least, that is equation number 1. So let me write over here. That is equation number 1. That is a plus b plus c equals to this. So let me use a green color marker, and that is how this thing is done. So therefore, the last thing, what is Tn? Tn is an squared. That is 1n squared minus 1n plus 1. Which is n squared minus n plus 1. Is that the answer? Yes, that's right over here. But I found it using subtraction in this case. Complete the table for diagram 4. That thing is done by considering the number of patterns. Complete the diagram. Find in terms of n the expression for x, y, and z. X is 3n, y is n plus 1 whole square, z is over here. So let me write over here. So therefore, which ones do we have? So let me just focus. X is equals to 3n, y is equals to this thing. I mean, the printing is not so good. And I think this is x is equals to 3n. And y is equals to n plus 1 whole square. And this is z equals to n square minus n plus 1. And this thing is also done. And now the last part, what exactly is that? Find the number of unshaded small triangles. Unshaded small triangles in diagram 100. So that is based upon this value of z. So now see, that is n is 100. That is 100 square minus 100 plus 1. So that is 1, 1, 2, 3, 4 plus 1 minus 100. And this answer is coming out to be this thing, 9901. And this is the answer, 9901 for this thing. All good, all clear. And that basically completes the lecture. So this is lecture number 4 of sequences. It's done and dusted. Everything is being taught. And that also completes the 27th lecture of algebra. Stay tuned for more.